Good afternoon, one and all. I am Vijayata, working as Assistant Professor in Triple Department, Institute of Technology, Bhimavaram. I am going to give a brief on single-phase induction motors. Why single-phase induction motors? The most available supply is single-phase supply. Single-phase induction motors are used in small equipment where we require less horsepower. Some of the applications in real life are pumps, compressors, small fans, mixers, toys, high-speed vacuum cleaners, electric shavers, and drilling machines. Even though there are a number of applications, these motors are not self-starting. Why single-phase induction motor is not self-starting? The figure indicates the construction diagram of a single-phase induction motor which contains stator, rotor, and main winding. When a single-phase supply is given to the stator field winding, it develops a revolving flux in one axis only. Hence, the rotor cannot start rotation. However, if the rotor is given an initial start by hand or a small motor, then the rotor will start rotation. How to make a single phase induction motor self-starting? A starting winding is connected at 90 degrees to the main winding as shown in the diagram. The flux phi1 is the flux produced by the main winding and phi2 is the flux produced by the auxiliary winding or starting winding. Now we can see how the rotating magnetic field is produced by these two fluxes, that is by adding an auxiliary winding. Consider the basic equations. Phi1 is the phi m sin omega t, phi2 is phi m sin omega t minus 90. Now, when omega t is equal to 0 at case 1, the resultant flux is shown phi r, which is downward direction. In case 2, when omega t is equal to 45 degrees, the phi r is shifted for some angle as shown. In case 3, when omega t is equal to 90 degrees, it is again shifted in this direction. And in case 4, when omega t is equal to 135 degrees, again it is shifted by some angle. Now, by considering all these 4 cases, the rotation of flux, that is resultant flux, is as shown. That is, if we consider 9 cases, the rotation of flux, in the case 1 it will be in this direction, in case 2 it is shifted some angle, in case 3 it is again shifted some angle. That is, by considering all the cases, we can understand that the flux is rotating in anti-clockwise direction when an auxiliary winding is added with respect to the main winding. The starting methods of a single phase induction motor. It is mainly classified into split phase motor and shaded pole motor. Depending on the method of starting, the name of the motor is given as like this: split phase resistance motor, capacitor start motor, capacitor start capacitor motor, permanent split capacitor motor. See, this split phase resistant motor is the resistance is added to the auxiliary winding in series. Here in capacitor start motor, a capacitor is added in series with the auxiliary winding. And next, in capacitor start capacitor motor, capacitor is connected both in starting and running condition of an induction motor. And in permanent split capacitor motor, the capacitor is connected permanently throughout the starting and running condition. All these 4 motors works same as the principle which I have explained before. That is, an auxiliary winding is connected with respect to the main winding at the time of starting. After it attains some 80 to 90% of its speed, then the auxiliary winding is taken off from the supply by a centrifugal. And now the motor works as a single phase induction motor. Rather than as compared to remaining motor, the shaded pole motor principle is totally different, which is explained as shown. This is a shaded pole motor construction. This is a poles which are present in the stator and rotor is a squirrel cage rotor. The pole is known as shaded pole. Why? Because the pole is cut at one end as a slot and a copper ring is attached to the slot. This part is known as unshaded part and this part is known as a shaded part. Coming to the principle of operation, when a single phase supply is given to this shaded pole, a positive half cycle and negative half cycle is as shown. During the positive half cycle, I have taken 3 cases at T1, T2, T3. That is from OA, B, C. That is till OA at T1. the increase of flux takes place. This increase of flux flows through the poles, and hence the change in flux takes place as the copper ring is presented here. Then the flux cuts the copper ring, that is conductor, and hence EMF is induced, and hence a opposing flux is created. The direction of this shaded pole flux is as shown, and this is the main pole flux. Therefore, due to the opposing flux here, the flux is reduced in the shaded part, and it is totally the amount of flux is shifted towards the unshaded part, and the magnetic axis line lies at the unshaded region. Again, in position T2, the voltage is constant, that is the constant flux flows through the pole. Therefore, there is no change of flux is there, and hence no EMF is produced, and hence the magnetic flux line lies at the middle of the pole as shown. Therefore, the shaded pole flux is 0 here. And in the next point, that is next to position T3, decrease of flux flows through the pole. Due to the decrease of flux, again change of flux is present, and hence EMF is induced, and hence the flux produced will oppose the reduce of flux. Therefore, the direction of flux is E as shown here. This is the shaded pole flux direction and main pole flux direction. Therefore, the magnetic flux line shifts to the shaded part. So by considering all the three cases, we can understand that the flux is first at T1 it is at the unshaded part, and at T2 it is at the middle of the pole, and at T3 that is at the shaded region. Therefore, the flux is rotating from unshaded region to shaded region by considering one pole. Similarly, we have 4 poles, the same procedure will be followed. So for all the 4 poles, the flux will be rotating from unshaded region to shaded region. Therefore, rotating magnetic field is created in the shaded poles. Therefore, the shaded pole motor is a self-starting motor by this small modification. Coming to the activities, I have conducted Kahoot activity. Nearly 45 students participated in this activity in one section, and these are the results, that is the answers given by the students. And I have presented a video for better understanding of a double field revolving theory in classroom, and I have shared the lab demonstration videos to students through Google Classroom. So total A and B section students participated in this Google Classroom, which the lab is demonstrated by both of our faculty members, and problem solving and assignments through the Google Classroom. Quiz, which I have given through the Google Classroom. I have conducted quiz, and these are the responses. Coming to the gate point of view, it is very important topic. Mostly the calculation of parameters and operating principle of single phase induction motor are very important. These are some of the previous repeated questions in this chapter. Thank you.